Hi everyone. Today we're going to be completing our notes on graphing sine and cosine with amplitude and period changes. I want to start off with the parent functions y equals the sine of x, and number two, y equals the cosine of x. So we'll start with y equals the sine of x. Actually, before we go ahead and graph this, I want to start off with some definitions. So we learned in yesterday's notes that periodic functions, we'll go ahead and define that again. So a periodic function is a function whose values repeat over an interval. Okay. A periodic function is a function whose values repeat over an interval. The period of a periodic function is the length of a cycle before it repeats, or another way to say it is the length of time it takes for the function to complete one full cycle. Okay? And then the last definition that we have is amplitude. So this is a new word for us. Amplitude is how high or how low, or how high above or below so how high or low above or below the midline. Okay? So the midline is going to be exactly in the middle of the graph. It's going to be exactly in the middle of the max and min. So in other words, it is 1/2 the difference between the max and min. Okay? All right, so now let's go ahead and graph the y equals the sine of x. So we'll start by constructing a table of values, x and y, where y is equal to the sine of x. Let's go ahead and plot all of our quadrantals. So reminder, our quadrantals are 0, pi halves, pi, 3 pi halves, and 2 pi. Okay? After 2 pi, the function repeats itself. So let's go ahead and evaluate the sine of 0. Sine of 0, remember sine corresponds with our y value. So our y value at 0 degrees, or I'm sorry, 0 radians is 0. At pi halves radians, we're looking at this point here, 0, 1. Our y value is 1, so therefore the sine of pi halves is equal to 1. The sine of pi, again, that's our y value at pi radians. Our y value is 0. 3 pi halves, our y value is -1. And 2 pi, our y value is 0. After that, it just keeps going around the circle and repeating all of those values again. So if we were to go ahead and sketch this graph, we would have 0, 0, pi halves 1, pi 0, 3 pi halves -1, and 2 pi 0. Now, I didn't fill in this whole grid. I'm going to ask that you fill in the whole grid. So notice that this pattern, it goes up, it goes back down, it goes back up. So this pattern is going to continue. I'm just going to sketch one cycle here. So these sine and cosine graphs are waves. So be careful when you're drawing them. We don't want to see any sharp corners or anything in our graphs. Here is one cycle. You might notice that the sine function, this is the parent function, it starts on the midline, it goes up to a maximum, goes back down to the midline and passes through, hits a minimum, and then comes back up to the midline. So this is the general shape of the sine function. Okay? Like I said, I want to fill in this grid, so I'm going to continue this pattern to fill in the whole grid. So as it goes up and passes through the midline, it's going to continue, hit that max, and then start to decrease. On the negative side, it's going to go down and hit that minimum, and then return back up to the midline. Draw those arrowheads. Make sure that the function does not exceed the maximums or drop below the minimums. So notice that my lowest points on the graphs are those minimums, those -1s. And likewise, all the highest points on my graph are 1s. It does not go higher than those points. Okay? All right, so all you have to do is graph one cycle and then repeat the pattern over and over to fill the grid. Okay, so the amplitude, again, the amplitude is how high or low below the midline that the function is. In this case, the parent function, the midline is going to be the x-axis, y equals 0. So the amplitude is going to be this distance from the x-axis to the maximum, or the distance from the midline, x-axis, to the minimum. And that distance is the same. That distance is 1. So the amplitude in this case, the height of the wave from the midline, is going to be 1. And that quantity is a distance, right? So distance is going to imply that this value is always going to be positive. And that's true for amplitude. Your amplitude will always be a positive quantity. The period. So what's the length of the function before it repeats? Well, if we notice that the shape of the sine graph starts on the midline, goes up, max, midline, minimum, midline, it follows that pattern. How long does it go before it repeats and starts back and ends where it started? And the answer is from 0 to 2 pi. So our period after 2 pi is just going to continue that same behavior. It'll go back up and back down and back up and so on. So our period here is 2 pi. We're saying that we get all those unique values or that unique behavior in one cycle of sine, which is 2 pi. Okay, the maximum, so the highest point on the graph, we have infinitely many of those. The maximum values are 1, and the minimums are -1. So we're looking at peaks and troughs, maxes and mins. Okay, let's go ahead and graph the cosine now. So we'll start with y equals the cosine of x. We'll start by plotting a table of values, x, y. Again, we're going to choose our quadrantals, 0, pi halves, pi, 3 pi halves, and 2 pi. So the cosine of 0, the x value at 0, that's going to be 1. Cosine of pi halves, the x value at pi halves radians, the answer is 0. Cosine of pi is -1, that's the x value at pi radians. Cosine of 3 pi halves is the x value at 3 pi halves, 0. And then finally, cosine of 2 pi is 1. So I'm going to go ahead and sketch this behavior, 0, 1, pi halves 0, pi -1, 3 pi halves 0, and 2 pi 1. Okay, so I'm going to go ahead and sketch this graph. Again, it's a wave, so careful for those sharp corners. We also don't want to exceed our maxes, and we don't want to drop below our mins. All right, so I'm going to just clean up my graph here real quick. There we go. Okay, so we're going to continue filling the grid. So I'm going to go ahead and plot the other points that are not reached by the first cycle. So I'm going to drop down and pass through the midpoint, the midline. Okay, draw those arrowheads because this wave does extend infinitely in both directions. All right, amplitude. So the amplitude in this case is that height of the curve from the midline. So the midline again is the x-axis, y equals 0. The amplitude is going to be 1. Period, again, for cosine is the exact same as sine, the length of the cycle before it repeats. The general shape of the cosine is that it starts at a maximum. So notice our y-intercept is a maximum. It drops down, passes through the midline, hits a minimum, comes back up, passes through the midline, and ends at a maximum. So here we have this behavior for the cosine. Notice the difference between the sine. Sine starts and ends at midline, and the cosine, positive cosine, starts and ends at the maximum. Okay. Period is 2 pi for both sine and cosine. Max and min are the same. We have a maximum of 1 and a minimum of -1. Okay, let's go ahead and try number 1, which is y equals the negative cosine of x plus 2. So we're going to do another table of values, x, y, and I'm going to choose my quadrantals again. I'm going to say 0, pi halves, pi, 3 pi halves, and 2 pi. So if I plug in 0, we have y is equal to negative cosine of 0 plus 2. Well, I know the cosine of 0 is 1, so we have y equals -1 plus 2 is 1. Okay. Moving on, we have pi halves. The cosine of pi halves is equal to 0. Make it negative is still 0. And then add 2, we get 2. So again, we're evaluating the function. We're plugging in these radian values anywhere we see x in the original equation. So y equals negative cosine of pi plus 2. Next one. Cosine of pi is -1. Make it negative is +1. And then add 2 is 3. Negative cosine of 3 pi halves plus 2. Well, we have cosine of 3 pi halves is 0. Make it negative is 0 plus 2 is 2. And then finally, evaluating for 2 pi, we get 1. Okay, so let's go ahead and plot these points. We have 0, 1. We have pi halves, 2. We have 3 pi halves, or pi 3, 3 pi halves, 2, and 2 pi 1. Okay, so we have this shape here. Again, careful, don't draw those corners. It's tempting to. It looks like it's like absolute value, but we want it to be a wave. So we want it to go up and then go back down. We want it to curve real nicely. And I'm going to redraw mine. There we go. Now this is one cycle. We're going to continue this pattern to fill the grid. Okay, so we've got that up and down periodic motion. Okay, so here's our graph here. The equation for our midline has shifted up 2. So our midline is going to be y equals 2. Start to consider if you see any patterns as to how we could find that algebraically or from the equation. Our y-intercept here is 0, 1. Okay. Next up, y equals 3 sine of x. So x, y. We're going to do our quadrantals again. 0, pi halves, pi, 3 pi halves, and 2 pi. So 3 times the sine of x, we have sine of 0 is 0 times 3 is 0. Sine of pi halves is 1 times 3 is 3. Sine of pi is 0 times 3 is 0. Sine of 3 pi halves is -1 times 3 is -3. And sine of 2 pi is 0 times 3 is 0. So we have 0, 0. We have pi halves 3. We have pi 0, 3 pi halves -3, and 2 pi 0. And I'm going to go ahead and just continue that pattern before I sketch in the grid, the graph, I should say. We have this motion here. Okay. So go ahead and sketch in the graph here. Be very careful with these tall, narrow waves. We want to make sure that they're nice and curved. Okay. So I want to show you something as we're drawing this graph here. So notice that at the end of the grid, we have that it hits a max, or this could also happen with a min. I often see students draw the graph like this and continue on upward. You have to be very careful when drawing these because these are maximum values. The function should not continue beyond that maximum value. So though it may be tempting to draw the graph to continue on beyond that maximum, you have to curve the tail of your graph downward because that is a maximum. The function does not exceed that y value. Our y-intercept in this case is going to be 0, 0. Okay, and as always, don't forget those arrowheads in both directions. All right, let's try example 2. Now we're looking at period changes. The first few examples were amplitude changes. You might notice that the height of the curve is different for number 2. We've got that vertical stretch by a factor of 3. Example 2, we're expecting a period change. This is a horizontal compression by a factor of 1/2. So if I were to create a table of values here, I'm going to ask myself for what values of x do I want that when I multiply by 2, I get those quadrantals. Okay, so I'm looking for those quadrantals, 0, pi halves, pi, 3 pi halves, and 2 pi. So I'm looking for what values when I multiply them by 2, I get those quadrantals. So what I can do is take those quadrantals and divide them by 2 so that when I multiply them by 2, I land back at those quadrantals. So I have 0, pi fourths, pi halves, 3 pi halves, 3 pi fourths, I'm sorry, and pi. Okay? And then our y values are going to be unchanged, right? Because we're only having a transformation to the input. So for a normal cosine graph, we have 1, 0, negative 1, 0, 1. So when I'm graphing this, I have 0, 1, pi fourths 0, pi halves negative 1, 3 pi fourths 0, and pi 1. I'm going to go ahead and continue that pattern and fill the grid. So you might notice that this graph, we've adjusted the scaling of our x values, our x increments on the x-axis. And the reason why is because this function, again, is compressed horizontally by a factor of 1/2. So this is a period change. It's going to change the length of the cycle before it repeats. So normally we have the cosine has a period of 2 pi. This one has been changed to have one cycle with a period length of pi units. The y-intercept in this case is going to be 0, 1. Now, you're probably wondering, how can we find the period algebraically, right? It has to do with this compression right here, this factor of 2 out in front of our input. So what we can do is we can take our normal value. When we talk about transformations, this is going to be our b value. That's that scalar multiple in front of the input. So we can take our b value, and we know that our period for a normal function, for a normal sine or cosine, is going to be 2 pi. We can find the period by dividing by that b value. So in this case, the b value is 2, so we get 2 pi over 2. That's going to give us our period of pi. So we can always find our period by setting up this equation here. So let's try that with number 2. Here we should expect a horizontal stretch by a factor of 2. So I would expect, if we're stretching by a factor of 2, that my period would be equal to 4 pi. But let's go ahead and try it. We have the period is equal to 2 pi over b. Well, our b value is 1/2. That's that number in front of x. So we have 2 pi over 1/2. That's going to be equal to 2 pi divided by a half, or 2 pi times 2, which is 4 pi. So that tells me that my period is 4 pi. Okay? So to get those 5 values, again, we could go from 0 to 2 pi and then multiply them by 2. So we have 0, pi, 2 pi, 3 pi, and 4 pi. Okay. Our y values for the sine are unchanged. This is only a transformation to the input. So we have 0, 1, 0, negative 1, and 0. And if you're ever in doubt, you can always plug in those values. So sine of 1/2 times 0, well, 1/2 times 0 is 0. Sine of 0 is 0. Plug in pi. Sine of 1/2 times pi is sine of pi halves, which is 1. And so on for 2 pi, 3 pi, and 4 pi. So let's go ahead and graph this. Here we have 0, 0. We have pi 1. We have 2 pi 0, 3 pi negative 1, and 4 pi 0. We can go ahead and continue the graph. Draw those waves. And we get this function here. The y-intercept is going to be the origin, 0, 0. Okay? All right. Just a few more today. Let's try y equals the sine of 2x plus 1. Okay, so here we have two transformations here. We have a horizontal compression by a factor of 2 and a vertical shift up 1. So let's use transformations. This is going to be affecting our period. So we know the period is going to be equal to 2 pi over b. And our b value in this case is 2. So we have 2 pi over 2, or just pi. So our period is pi units. And then, so we have from 0 to pi. So we have 0, pi fourths, pi halves, 3 pi fourths, and then pi. Our y values for the sine are going to be the same, but then all shifted up 1 unit. So we have 1, 2, 1, 0, 1. So instead of 0, 1, 0, negative 1, 0, it's all going to be shifted up 1, and that has to do with this vertical shift up 1. Again, you could always plug in these values, okay? When in doubt, plug in those values and evaluate. It takes a little bit longer, and I'm hoping that you start to see some of these patterns, and you can start doing some of these without needing to evaluate. So here, I noticed that we have 0, 1, pi fourths 2, pi halves 1, 3 pi fourth 0, and then pi 1. Okay? Go ahead and draw the rest of the points to finish the pattern. Fill the grid. And we have this shape here. Draw your wave. Watch out for those corners. Also, the endpoints, we start at a max on the left-hand side of the grid, and we end at a minimum on the right-hand side of the grid. Be sure to curve your ends back up and back down. Okay, we don't want to see those values exceed the max and min. The y-intercept in this case is 0, 1. Notice that the equation of our midline, again, is y equals 1. I'm going to ask again, what do you notice about the midline, the equation for the midline, and the equation? See if you can draw those patterns. The answer is that vertical shift is going to define our midline. Okay, last example, y equals 2 cosine of 1/2 x. So we're going to start with transformations to the input. This is a horizontal stretch by a factor of 2. So we're going to choose values from 0 to 4 pi. Now this graph is centered at 0, 0, and we're going from negative 2 pi to 2 pi. So instead of going from 0 to 4 pi, let's consider going from negative 2 pi to positive 2 pi. And that way our graph is going to be centered at 0, 0, but it's still going to have a period of 4 pi. Notice that we're still going from negative 2 pi to 2 pi, so then our period is 4 pi. Our y values are going to be double the regular cosine. So remember, cosine starts at a maximum and ends at a maximum. We have this shape here. Starts at a maximum, so 1, but we're going to multiply it by 2. So we get 2, 0, negative 2, 0, and 2. So let's go ahead and sketch our graph here. Oh, I'm sorry. So actually this is starting at negative 2. So actually it's going to shift everything. So actually let's go back and erase those. Negative 2. If we were to plug in negative 2 pi, plug in negative 2 in for x, you get that cosine of pi, which is negative 1 times 2 is negative 2. There we go. That's better. Plug in negative pi, you get cosine of negative pi halves, which is 0 times 2 is 0. Plug in 0, you get cosine of 0, which is 1 times 2 is 2. And then plug in pi, you get 0. And then plug in 2 pi, you get negative 2. There we go. Okay, so that is correct. Now we have negative 2 pi, negative 2. We have negative pi 0. We have 0, 2. We have pi 0. We have 2 pi, negative 2. So here we've got this real stretched out cosine graph that's centered at 0, 0. All right, here we go. Don't forget to curve those endpoints up, those tails. Our y-intercept is going to be 0, 2. And our period, again, is going to be 4 pi. That's 2 pi over b. Okay. All right, so this has been graphing sine and cosine with amplitude and period changes. We're going to get a lot of practice on this, so we'll see you tomorrow in class. Goodbye, everyone.